Hi everybody! Today we will talk about radioactivity. Another information given in the periodic table we did not discuss yet. Radioactivity. All metallic printed elements are radioactive, for example radium, francium and uranium. Most of you might have already heard this term, but what exactly is that? When we talked about atomic masses and isotopes, we already touched upon radioactivity. The natural carbon isotope C14 and all artificial carbon isotopes are unstable. Radioactivity describes the property of unstable atomic nuclei to emit ionizing radiation. This causes the atomic nucleus to transform into another atomic nucleus by emitting particles, or it changes its state by emitting excess energy. If carbon has radioactive isotopes, why is it not highlighted as radioactive in the periodic table? In the periodic table, only elements are marked as radioactive when all the isotopes are radioactive, which is not the case for carbon. If you want to find out more about different isotopes and which ones are radioactive, it is better to not look at the periodic table, but in a table of nuclides. This picture here is a screenshot of an interactive table of nuclides, which I will link in the description. The y-axis shows the number of protons, and the x-axis the number of neutrons. Like this, all the different isotopes can be shown. In a table of nuclides, you can find different information about the isotopes. Let's look at C14. It has 6 protons and 8 neutrons, so overall 14 nucleons. When zooming in, we can choose C14 and see the information. One given info is the half-life, which is 5,700 years for C14. The half-life describes the time necessary for half of the nuclei to emit radiation. This time is independent of the number of unstable atoms. To explain that more detailed, we have a look at 64 unstable atoms with a half-life of 10 years. Over a time span of 10 years, 32 atoms decay, so that only 32 atoms of the original unstable nuclei are left. However, after another 10 years, so overall 20 years, the leftover 32 nuclei do not just decay, but only half of them does. Therefore, only 16 nuclei decay, leaving 16 unstable nuclei. The same happens after another 10 years. After 30 years, only 8 unstable nuclei are left. C14 has a half-life of 5,700 years. So, if we would have 64 C14 atoms, it would take 5,700 times 3, so 17,100 years, to only have 8 C14 atoms left. This was an overview over radioactivity. If you have questions, suggestions, or tips, leave them down in the comments. If you liked the video, like it and subscribe to my channel. See you in the next one.